Hello everyone, and welcome to this example solution lecture for the Linear Regression Consulting Project. What we're going to be doing is walking you through and coding along an example solution for the Linear Regression Consulting Project. If you did it another way, that's totally fine. This is just an example of one possible solution. Let's hop over, create a new notebook, and get started. Okay, so the first thing we have to do, regardless of whatever approach we take, is start a Spark session and get the data. So let's go ahead and do that. We'll say from PySpark.SQL import a Spark session, and then we'll say Spark is equal to Spark session builder app name, and then we'll call this app cruise, and we'll say get or create. And the next thing we're going to do is actually read in the data. So hopefully you recognize that it's a CSV file. So all you have to do is say spark.read.csv, and we should also infer schema to be true, as well as set header to be true. So we'll run that analysis, and then what we want to do is print out the schema just to get a taste of things here. So we can see we have the ship name is a string, the cruise line it belongs to is also a string, the age is an integer, we have the tonnage, the passengers, length, cabins, passenger density, and crew. So we see that we have all these numerical concepts here, and we have two strings, the ship name and the cruise line. So if we take a look at some of the first entries, so let's say df head of 5, and let's actually say for ship in df head of 5, we will print ship and then print a new line. This is just so it looks a little nicer for us here. So let's run that. Okay, so I can see that the ships have various names, journey, quest, celebration, etc. But the cruise lines sometimes are shared. So we have one cruise line here with multiple ships. The Carnival cruise line has the ship celebration, the ship conquest, etc. And what we noted here is that the cruise line may have an effect on how many crew members we need. So maybe certain cruise lines try to increase the number of crew members, or certain cruise lines compared to others have fewer crew members. So that's something we want to explore, but since it's a string argument or a categorical data point, we're going to need to use string indexer to convert it. If you weren't able to figure that out on your own, no problem. There's still plenty of information here that's totally numerical and lines up with the examples we worked through earlier. We can see here the age of the ship, how large the ship is in tonnage, how many passengers it can hold, the length of the ship, number of cabins, passenger density. Those are all things that intuitively would relate to the actual number of crew members needed. So if you have more passengers, or your ship is larger, or there's more density of passengers on the ship, you're going to need more crew members. And likewise, if you have less of that stuff, you probably need less crew members. But let's convert this cruise line feature into some sort of numerical value that our algorithm can understand, because the algorithm cannot understand directly something like Carnival or Azamara, whatever, etc. So let's come down here, and what we're going to do is work with dealing with that cruise line categorical variable. So let's just see how many cruise lines we have in general. And what I can do is say group by that cruise line, and it's cruise underscore line column. And then I just want to count and then show the results there. So what this is going to do is it's going to group by the cruise line and then show the count. And I can even order this if I wanted to, but I can see here that it looks like there's quite a few cruise lines. And what I can also see is that certain cruise lines have a lot of ships and certain cruise lines have way less ships. That's something we may want to explore later on. But it's worth it, especially because that client, Hyundai Heavy Industries, indicated that this may be an important feature, which is why we're going to explore it further. So what we can do is use string indexer to try to convert these various cruise line names into just number groups, so 0, 1, 2, 3, etc. So let's try to do that. What we're going to do is say from pyspark.ml.feature import string indexer. And then I'm going to create an object called indexer, and this is essentially going to look really similar to a vector assembler object. So we're going to say input column is cruise line, and then say output column, or output call is, we'll say cruise underscore cat, so cruise category. And then what I will say is indexed is the indexer, and then you fit the indexer to the data frame, and then you can also then transform this. So I'm doing this all in one step, but you could separate this out into two lines. So if you wanted to, you could take this object and then on another line do the transformation. I'm just doing it here on one line, these two steps. So then what we're going to do here is say let's show indexed head 5. Or let's just show 1, since we only need to see 1. And here I can see the ship name, journey, cruise line, and then if I come all the way over here, I can see this particular cruise category is now assigned at number 16. If I see something like cruise head 3, if we continue down, we can see again this same cruise line is category 16, but maybe if you're on Carnival Cruise Line, your cruise category number 1. So now that's a numerical value that the algorithm can use versus just this string value. Now there's definitely different ways to deal with string categorical information. Beyond this, you can separate this out into what's known as dummy variables. So then you have a single column indicating yes or no for every cruise line. But we're going to keep things kind of loose and just set it as some numerical category here. This is not the most optimal way to deal with this, but it should be enough for our particular use case, especially since we have so much more numerical data here. All right. So continuing on, don't worry if you weren't able to figure that out. We'll discuss working with categorical data much more in future lectures. But what we're going to do now is move on to working with the vector assembler and just getting our linear regression working. So I will say from PySpark.ml linalg import vectors, and then from PySpark.ml.feature import vector assembler. So that's what we've seen earlier. And then if I look at the indexed columns, so that's my new data frame that now has this cruise category, I can see the actual columns that I want to include. So what I will end up doing is creating an assembler object, and I'm going to set it equal to the vector assembler, and now I want to define my input columns. So what I always like to do is just copy and paste these. So I don't want the cruise line, I don't want the ship name. The ship name is just some arbitrary string. The cruise line I've already converted to this cruise category, and I don't want the crew column. So what I'm going to do is copy all of this, and then make sure to get rid of crew, because crew is what I'm trying to predict, it's not a feature. And now I'm good to go. So notice that I have my age column, tonnage, passengers, length, cabins, passenger density, and then my cruise category. Those are my input feature columns, and then my output call is going to be just features. So let's run that, and let's make sure we wrote that right by saying output is equal to that assembler object and transform indexed into that. Okay, the reason we have to do indexed and not data is because remember index is the one with the cruise categories. So what we can do now is check it out and make sure we're good to go. So I'm going to say output select features and then crew and show the results here. So now I can see I have my various features and then my label column, which is just crew. Great. And we can also see that certain ships that are basically the exact same make and model have a certain number of crew. So that's good to note here as we explore this data further. So continuing along, let's create our final data, which is going to be equal to output select, and all I care about is that features column and that crew column. And note here that I'm not passing it in as a list. That shouldn't be necessary, but in case you're getting errors for certain versions of Spark, you may need to do a list like this. Okay, so moving along, I'm going to do the train data split, or train test split, I should say. And we'll grab our final data and do a random split on it. And I'm going to split it into a 70-30 mix. And let's explore that train data. So I'm going to ask it to be described and then show it. So in my training data, I have 103 ships. That's not so bad. And then in my test data, we're going to describe this, show the results. And then I have 55 ships that I'm going to be using for testing. So what we're going to do now is finally build our linear regression model. From PySpark.ml regression, I want to import a linear regression object. And now let's create a linear regression model object. So I will call this ship LR, and I will set it equal to linear regression, but I also need to specify that my column, my label column at least, is going to be crew. If you come back up here, remember that we have features, but we also have crew instead of label. So we need to select that. So I'll come over here, say linear regression, label column is crew, run that, and then off of this ship LR, I'm going to say, let's say trained ship model is going to be equal to ship LR, and I'm going to fit this to my training data. So now that's fit to my training data, I can check out my trained ship model. Whoops, trained ship model. And now I can evaluate my test data. And then do this as ship results. Run that, and let's check out our ship results. So I can just check out things like the root mean squared error. And I can see that my root mean squared error here is 0.67. Now remember the units here, if I take a look at my actual data, so for example, my training data, and let's say describe show, so we can actually see the crew count. The crew count is in counts of 100 with the mean value being around 7.7. So as always, this root mean squared error is meaningless unless you compare it to the actual crew values. So crew values were in those units, I believe it was in hundreds. You can see here that the mean was 7.7, standard deviation 3.65, min being 0.59, max being 21. So the root mean squared error is actually looking pretty good. Now let's go ahead and check out some other metrics. We can call ship results and check out our squared value to see how much of the variance is explained. And in this case, we're explaining quite a bit of the variance, 0.95. Now, depending on how your random split occurred, you may be explaining a little less or a little more. I would suspect that given whatever random split you did, you should have achieved at least 0.8 R squared value. In the actual solutions notebook, when I was running this the first time, I achieved around 0.86. Because there is a random split here, if we come up here, so because of this random split on 0.7 and 0.3, depending on two things, one, what actual random splits you end up doing, and two, what values you choose here, your results may differ than mine. So if you have less training data, you're going to be a little less accurate. But keep in mind, your results won't be exactly as shown in the solutions notebook or in this video because of this random split. So coming back down, we got a really good R squared value and a pretty darn good root mean squared error. And we can continue to analyze different things about this. For example, if we wanted the mean squared error, we could grab the ship results and then call mean squared error. There's also mean absolute error that we can check out. So we'll say mean absolute error, and that's 0.53. Now, as I mentioned in the previous code along lecture, if you're getting really good results on things like root mean squared error, and you're getting a really high R squared value, it's always a good idea to kind of do a reality check on your results. It doesn't make sense that you're getting this good of a model. Now in this case, this data is actually real. It's not artificially created. This is real data on real ships gotten from the UCI machine learning repository. That's UC Irvine's machine learning repository online. So what we can do to kind of do a reality check on these results is see if the two columns, or any two columns, are really highly correlated. So things I can do is check, is the number of crew highly correlated with the number of passengers on board? Or is the number of crew highly correlated with the number of cabins on board? If those things are true, then it makes sense that my model performed really well because there's two columns that are really highly correlated with the thing I'm trying to predict. So let's do that. I will say from PySpark.SQL.functions import CORR. And that stands for the Pearson correlation, which is basically just a way of saying how related are these two columns. And what I'm going to do is, if I take a look at my original data frame, so let's make sure I did save it under DF. Okay, so I did. So I want to check if in my original data, is this crew column really related to things like the cabins? So we'll say DF, select, and then I'll pass in the correlation, and I'll pass in the crew column, as well as the passengers column. And let me show the results here. So I can see here, based off these results, that these two columns are highly correlated, with 1 being perfect correlation, so 0.91 does signify high correlation, which makes sense just intuitively. If there's more passengers on board, you'll need more crew. Or likewise, if there's less passengers on board, you'll need less crew. So it makes sense that these are highly correlated. And if I check it against another column, such as cabins, then I get an even higher correlation, 0.95, so more cabins, more crew members, which means that just a lot of these features of the ship itself have a really good indication of exactly how many crew members we need. So all of that makes a lot of sense, both intuitively, just from thinking about more passengers, more crew members, and mathematically based off these correlations, as well as the results of how well our model performed. Okay, So hopefully you got the basic idea of how to test out the model and create a model trying to predict the number of crew members. If you weren't able to figure out string indexer, don't worry, that's no problem. We're going to be covering categorical data in a lot more detail for future models and future projects. Hopefully, however, you were able to create some base linear regression model that had good results, or at least fair results, in trying to predict how many crew members were needed for new ships. Thanks, I hope you enjoyed that, and I'll see you at the next section of the course.